Well, Assalamu alaikum, dear students. I am Engineer Abdul Basit, and we are in week number 10, lecture number 19 of Geotechnical Engineering 1. The topic we are going to discuss today is Shrinkage Limit, Liquidity Index, Consistency Index. Okay, so first of all, coming to the first topic, the Shrinkage Limit. As we have discussed in previous few lectures, that what is liquid limit, what is plastic limit, and what is plasticity index. So this is actually the continuation of the same topic. uh, First of all, shrinkage limit is basically the actually again the moisture content and the property of the moisture content, as it used to be the moisture content is also like being discussed in the liquid limit and plastic limit. So before going to shrinkage limit, let me remind you these liquid limit and plastic limit phenomena. uh, Liquid limit is actually that water content at which the soil starts to behave like water. Okay, so any further increase in the water content after that limit will make this soil sample more like fluid. More like fluid mean it will have properties like fluid, like for example, it will start flowing when it is poured on the floor. Okay, and similarly, talking about the plastic limit, so again this is the property of moisture content. It is actually that limit or that amount of moisture content at which the soil starts to behave like plastic. Okay, so plastic simply mean that the plastic type of properties. For example, whenever you apply force on that soil, a permanent deformation will occur in the soil and its volume will change. Okay, so it will be like a paste of the soil, as you have already may have already seen in our daily lives. Okay, so now coming towards the shrinkage limit. So again, shrinkage limit is the property of moisture content. Okay, so let me tell you in this in a form of a story. Let's say we have a soil sample and it is having some specific amount of water, and at that amount of water it is behaving like liquid. Okay, now if we keep it in oven, started to dry it with any other mean, so what will happen? The soil, the moisture content will get reduced and the soil will be converted to plastic. Okay, then if we further decrease that moisture content, so the soil moisture content will be reduced, and the soil will start to behave like solids or semi solids. Okay, so whenever you are decreasing that moisture content, the volume of the soil will also decrease gradually. Okay, so the loss in the moisture content will cause a decrease in its volume. Okay, so then a stage will come when you are decreasing the moisture content, so continuously you are getting a decrease in the volume as well. But a stage will come when after that, when you are decreasing the moisture content, there will be no any such change in its volume, no any reduction in its volume. So that point, at that point, the moisture content is actually called the shrinkage limit. So here in the definition you can see that simple, the moisture content is, here you can see uh, this thing, let me highlight it for you. The moisture content, okay, in percent, the moisture content in percent at which the volume of the soil mass ceases to change is defined as the shrinkage limit. So at this stage, there will be no any such change in its volume. So at this point, the moisture content is actually called shrinkage limit. Okay, so I hope you got the definition. Now how to find out the shrinkage limit? What is the test for it? So the test is actually designated as ASTM D427. So this is the test we are normally using for that shrinkage limit determination. So we will discuss this in detail in our labs. Okay, so these are few tools used for it. Let me pick my point of interest from this lecture. uh, Here it is, this thing, how this test is actually performed, what is the phenomena. So first of all, a paste of the soil is prepared. Okay, how it will be prepared: take a soil sample in a cup, and then pour some water in it. Okay, make a paste, mix it thoroughly, then place this paste in shrinkage limit or shrinkage index dish. Okay, this is like a cup made up of steel. Okay, you can see here in this picture, this is actually placed here. Okay, so how can you do it again? uh, just you have to place the paste here. Let me go back to my presentation. Okay, sorry for this small interruption. uh, Actually, if you prepare that paste and place it in the cup, this cup is actually made up of steel, and the walls of the cup is internally oiled, so that the paste may not stick to it. Okay, then at this stage, when the paste is prepared and kept in the cup or the dish, okay, the weight, or you can say the moisture content, is determined. Okay, then this sample is placed in an oven, and to make it dry or to evaporate the moisture content from it. Then after some time, when it is taken out, so the situation will looks like this. Okay, why it is so? You can see this paste have used all the volume of the dish. Okay, but now in this picture you can see the volume of the paste is being reduced, and there is a visible space between the wall of the cylinder and the paste. So the volume of the paste is actually reduced significantly. Okay, so now you can see this graph shows the same situation. Like at this stage, initially when the paste is prepared, you have the moisture content, that is Wi or omega I, initial moisture content. When you start on reducing the moisture content by placing it in oven, you will see a continuous reduction in the moisture content. Here in the abscissa you have the moisture content, so you can see, you can observe a continuous reduction in the moisture content, and at the same time you have a linear relationship between the volume reduction as well. So the volume at this stage is Vi. Okay, and at the final stage, at the shrinkage limit, it is Vf. So there is a significant volume change, which you can find out by subtracting this Vf from Vi. Okay, now uh, delta omega, this is also the change in moisture content. Okay, which is happen to be by placing it in the oven. Okay, so whenever you are reducing the moisture content, so as this paste is like in the liquid form, so the first thing, the first limit that will arrive in the way is the liquid limit. Then on further reduction in its moisture content, we will see the plastic limit as well, and then the at the end, when the total the moisture content is reduced and being removed, so you will see that shrinkage limit at this stage. Okay, so there is a direct relationship, or a linear relationship between the change in volume and the moisture content. But at this stage you can see we are reducing the moisture content, but there is no any change in its volume. On the ordinate you can see there is no change in the volume, and at the moisture content is continuously reducing. Okay, so you can say this is actually the shrinkage limit point. According to definition, you have already listened to this, that the shrinkage limit is that point, or you can say the moisture content at that point at which you can see, you can observe no any change in its volume on any further reduction its moisture content. Okay, so this is that point at which you can see no further change in volume, but there is a moisture content reduction. Okay, so this graph is showing the same thing, and this will be used in the test as well. Okay, how to determine the shrinkage limit? Very simple. The just subtract that change in its moisture content from the initial moisture content, that is like the moisture content of the paste. Okay, so you do have the knowledge about this, what is wi, omega I, and the change in moisture content. Okay, how to determine this moisture content? So this is that simple formula we have used in the previous lectures as well, that m1 minus m2 divided by m2 multiplied by 100 is how to determine the moisture content at any stage. Okay, so if we are talking about that moisture content at the initial stage of the paste, so you have that m1 means mass of the wet soil pat in the dish at the beginning of the test. Okay, and m2 is mass of the dry soil pat when it is being taken out from the oven. Okay, so this will be that situation. So here, moving on, liquidity index. What is liquidity index now? So in the this is again that engineering property of the soil, which tells us about the relative consistency of cohesive soil in natural state. Okay, natural state mean the soil placed in its natural state in the on the ground. Okay, you have taken any undisturbed sample or a disturbed sample. Okay, then you have calculated its moisture content, its liquid limit, its plastic limit, or all these things. Then you can find out its liquidity index by using this equation. What does this equation mean? This omega is the moisture content minus plastic limit divided by liquid limit minus plastic limit. So this is that simple equation to determine the liquidity index. Okay, so in the coming slides I'll tell you what is the difference between liquidity index, liquid index, and shrinkage and index, all these things. Now, omega, in situ moisture content of the soil. So as we are talking about the in situ situation of the soil in its natural form, then this should be the in situ moisture content of the soil. Okay, liquidity index will be greater than 1 when, in which situations, in what case? When in situ moisture content of the sensitive soil is greater than the liquid limit. When moisture content is greater than the liquid limit, or the moisture content in the natural state, in situ state, is greater than the liquid limit, so definitely you will get that numerator is greater than the denominator. So the answer you will get from this equation will be greater than 1. Okay, as the plastic limit remains same in numerator and denominator. So just the depend is on this omega and this liquid limit. Okay, so if this omega moisture content is greater than liquid limit, so you will get a value greater than 1. If this moisture content is less than the liquid limit, so you will get a value that is less than 1. Okay, so here it is, how this situation will occur when the liquidity index is less than 0. How it will be when the soil is remolded and transformed into a viscous form to flow like a liquid. Okay, like you can say the soil is remolded or disturbed, and and water is added to it, and it starts to behave like liquid. Okay, then you will get a situation when the moisture content will be less than that plasticity limit or plastic limit. Okay, so this equation will be like, you can say the moisture content will be less than this plastic limit. So if this first term is less than this plastic limit, so definitely you will get a negative number over here. Okay, a number that is less than 1. Okay, less than 0. And then anything less than 0 divided by anything, you will get the result as in negative. Okay, minus this thing, minus this thing, minus this thing. So this will be like a less than 0 value. So the situation will become like this. Okay, liquidity index is less than 0 or a negative value. Moving on, coming to the consistency index. Okay, consistency index is actually denoted by CI. Okay, this is another commonly used engineering phenomena, or in many engineering purposes, especially in the design of foundations. Okay, so uh, consistency index can be calculated by this simple equation. You can see it here. In previous slides you can see, here it is. Okay, liquid limit minus water content divided by liquid limit minus plasticity index. So this equation shows when the moisture content is equal to that plasticity index, these values are the same. Okay, so definitely this first term is same in both numerator and denominator, so this will lead us to a value equal to 1, because numerator and denominator will give us the same value. Okay, uh, but keep it in mind, this moisture content is the moisture content in situ. Okay, not in the laboratory. Like this is not talking, we are not talking about artificial samples that is being prepared already. We have discussed in previous few tests that were conducted for the plasticity index, for plastic limit and liquid limit. So in these tests we can prepare the sample artificially in lab by adding water to it and removing water from it. Okay, making it dry. But here in this consistency index and in that liquidity index, in both cases the moisture content will be in situ moisture content or in the natural form. Okay, now already in previous lecture or Zoom session we have discussed that the plasticity index is actually the liquid limit minus plastic limit. So this is actually the area or the length or the values that are coming between liquid limit and plastic limit. Okay, this is called plasticity index. Okay, so you can see at the limit or the liquid limit, you can have liquidity index equal to 1, but at the plastic limit the liquidity index will be equal to 0. So this is quite simple. The liquidity index, from here in this equation you can see, whenever you have that liquid limit equal to liquid limit, here it is, liquid limit equal to liquid limit is at liquid limit you can get the value of liquidity index equal to 1. How? Just by putting this liquid limit on in that equation. At this stage you have that liquid limit equal to some value. This will definitely have some value, but at this stage the liquid limit have no value and this is equal to 0. So that's why liquidity index also given by this equation will be also equal to 0. Okay, now if we are keeping keep on the increasing in the moisture content, so again you will get that value of liquidity index greater than 1. Okay, moving on, inshallah, in the next lecture we will discuss about um the plasticity chart and that activity. Okay, so thank you very much for listening. Assalamu alaikum.